Hi students, in this video we're going to look at how to use trigonometry to calculate unknown side lengths. So after watching this video you should be able to select the right trigonometric ratio to solve a particular problem and then calculate the value of an unknown side of a right angle triangle. So some things to recall. First of all, labeling the sides of your right angle triangle as hypotenuse, adjacent and opposite. Needing to know those is very important. And also your trigonometric ratios, sine, cos, and tan, using whatever method or mnemonic, whatever you use to remember those will be important as well. Alright, so for calculating unknown side lengths, the first step is to label the sides of our right angle triangle. That will be the same in any sort of trigonometric problem. Hypotenuse, opposite, and adjacent. Once you realize what sides you're given or what sides you have to find out, you can then select the correct trig ratio to use, create your equation by substituting into the formula, and then rearranging and solving for the unknown. Alright, so a couple of examples. Calculate the unknown sides in the triangles below. Our first step is to label our sides. So we've got our hypotenuse is the long one, our adjacent is the side next to our reference angle, and our opposite side is on the other side of our reference angle. So the ratio we need to use in that case then is cos, because we have the hypotenuse and we want to find the adjacent, so it's ka. So katoa, so cos of our angle equals adjacent over hypotenuse. Doing some substitution, so cos of 25 degrees equals x over 3.2 meters. Now to rearrange that, all we'll have to do is times both sides by 3.2. So we've got divide by 3.2 on this right side. To get rid of it, we'll times by 3.2. So we end up with 3.2 times cos 25 degrees equals x, and that value is 2.90 meters. And that answer makes sense. Our hypotenuse is 3.2 meters, so our adjacent must be smaller than that. And 2.9 seems reasonable, looking at the diagram there. Alright, and then second example, again we'll label. Hypotenuse is there, adjacent is next to our angle, this side over here is opposite our angle. So here we're going to use tan, because we have our opposite side and adjacent side. So tan of our angle equals opposite over adjacent. So tan of 77 degrees equals 18 over x. Now, this one here looks a little bit different to the first one because x is in our denominator now, not our numerator like it was in the first example. So what we're going to do is still the same thing. We're still going to multiply both sides by the denominator. So multiply both sides by x. So those x's there cancel each other out. So x times tan 77 equals 18. Now what we want to do is still get x on its own. So x we want to keep, but the tan 77 has to go. We're multiplying by tan 77, so the opposite of that is divide by tan 77. And those two will cancel there. So ultimately, we get x equals 18 over tan 77 degrees, which equals 4.16 centimeters. Once again, that seems reasonable because large sides, like this 18, this long side is opposite a big angle. This angle up here is much smaller, so the side opposite must be much smaller. So x should be smaller than 18 because it's opposite a smaller angle. Our answer is 4.16, so our answer is definitely smaller. Seems reasonable. Right, so after watching this video, you should be able to select the correct trigonometric ratios to use when solving a problem and also calculate the value of an unknown side in a right angle triangle.